will learn how to solve inequalities. Let's start by solving inequalities by adding and subtracting. Remember, after you solve an inequality, if the variable is on the right-hand side of the inequality, before you graph it, rewrite it with the variable on the left-hand side. This makes graphing easier, and you can draw your arrow in the same direction as the inequality symbol. Let's try this first example together. 5 plus x is greater than -2. When we solve an equation, we're trying to figure out what one value of x makes this statement true. When we solve an inequality, there are actually infinite number of possibilities that make the statement true because we are trying to not find an exact number equal to -2, but any sum that is greater than -2. So first you're going to subtract the 5 just as you would if this was an equal sign. You end up with x is greater than -7. This means any number that's bigger than -7 would make that inequality statement true. While we cannot possibly write every single number that's greater than -7, we can draw a number line to show all of those possibilities. When I draw my number line, I like to put the number that is in my solution right in the middle, and then one to the right and one to the left. Since this is greater than, that is an open circle, and all the values bigger than -7 are to the right of -7. In example number 2, I would start by adding 10 to both sides. When I add 10 to -4, I get 6 is greater than or equal to r. However, when I want to graph this, it is easier to graph when the variable is on the left-hand side. So I'm going to first rewrite it so that r is on the left and 6 is on the right. When I rewrite it, we have to be careful and make sure that our inequality symbols are facing the correct direction, which would look like this now. My goal is to keep the open part of the inequality symbol facing the 6, so my answer reads r is less than or equal to 6. This would give me a number line where there is a closed circle on the number 6, and everything to the left of 6 is shaded in, showing all of the numbers less than 6. Take a moment to try this one on your own. When you subtract 9, you end up with -8 is less than or equal to g. If I'm going to graph this, I'm going to rewrite it as g is greater than or equal to -8, giving me a number line that looks like this. Open circle, shading to the right of -8. Now let's take a look at how to solve using multiplying and dividing. Similar to adding and subtracting, we use the same process as we did if it was an equal sign. When we multiply or divide by a positive number on both sides of the inequality symbol stays the same, just like it did for adding and subtracting. Let's take a look at these two examples side by side. First, in this example, I would divide by 2 on both sides, which would give me an answer of x is less than -6. My number line would give me an open circle on the number -6 and shading to the left of -6. In the second example, I would multiply both sides by 5, giving me -5 is less than or equal to x, or x is greater than or equal to -5. This number line would have a closed circle on the -5 and shading to the right. Let's take a look at this chart for a moment before we look at the next two examples. If I begin with the inequality 4 is less than 7, we can certainly say that that indeed is a true statement. If I alter this inequality by multiplying on both sides, the 4 and the 7 by 2, I get 8 and 14, and that same inequality symbol of less than, 8 is still less than 14. As long as I do the same thing on both sides and my answer doesn't change, my inequality symbol will not change. However, if I multiply 4 and 7 by a -2, we get -8 and -14. No longer does the original less than symbol work here. Since 4 times -2 is -8, and 7 times -2 is -14, -8 is actually now greater than -14. This occurs because when you multiply a positive times a negative, you get a negative. And the -8 is greater than the -14, whereas a +8 is less than the +14. Let's take a look at how this appears when we're solving an inequality. If you multiply or divide by a negative number when you're solving your inequality, you are going to flip the inequality symbol to its opposite. Taking a look at this as an example. In this case, I'm dividing both sides by a -2. The number that I am dividing by is this number. When that number is a negative, in my answer, I'm going to flip this from x to -2x is less than -12 to x is greater than a +6. When I draw my number line, that's going to show an open circle on the number 6 with everything shading to the right. Before we try the second example, let's just take a look at why this is true again in another way. If I left my inequality symbol as a less than, if I choose a number less than 6, let's say I choose 2. If I plug 2 into my original inequality, -2 times 2 is -4, and -4 is not less than -12. It is greater than -12. So if I pick a number that's less than 6, that number does not work. If I pick a number that's greater than 6, let's say 7, -2 times 7 is -14, which is indeed less than -12. So as you can see, if I did not flip my inequality sign from the less than to the greater than, none of those answer choices that are less than 6 will actually work in the original inequality. It's required to flip the inequality to get all the values that will work in the inequality. Let's take a look at this example over on the right. -1 is less than or equal to -x over 5. To solve this, I need to multiply both sides by -5. This allows for not only the 5's to cancel, but the negatives to cancel as well, leaving us with a positive x. And a -5 times a -1 gives us a +5. Since I multiplied on both sides by a -5, I need to now reverse my inequality symbol so that it is 5 is greater than or equal to x. If I need to graph this, this is where we need to be a little extra careful. This is going to be a closed circle on the 5. But since the x is on the right, my inequality arrow is not going to go to the right, it's actually going to go to the left. If I rewrote my answer, it would look like this. X is less than or equal to 5. Basically, I'm reading it in the other direction. So if x is less than or equal to -5, my shading would be to the left. Let's take a look at a series of questions and see if we can determine which one would need to have the inequality sign flipped because it is multiplied or divided by a negative. In these examples, this one in the top right and the one in the bottom left would be the ones that would require the inequality sign to be flipped. These other two do have the x on the right, so I can reverse my answer to put the x on the left, but those would not require that the inequality itself flips unless everything else is being reversed. Take a moment to solve these. If I divide here by 7, I end up with a -4 is greater than x. I do not need to flip the inequality sign unless I'm going to reverse or rewrite the entire answer so that the x is on the left. In this example, I should multiply both sides by -2 over 1, which causes my inequality sign to have to flip because I multiplied by a -2 on both sides. My answer here would be x is less than or equal to -6. When I solve this next one, I'm going to divide by a -3, which would require me to flip my inequality since I divided by a -3. And for my final example, multiplying both sides by a 4 would simply give us a +32 is less than or equal to x. And again, that answer, if I rewrite it with the x on the left, would be x is greater than or equal to 32. Here are a few other examples for you to try.